All right, so good morning, everybody. I'm Tom Hardwicke from the University of Melbourne, and it's a pleasure to be here today representing our team, Robbie, Stylianos, and Fallon, and to share with you our project proposal for the Open Science Observatory. So this is a data dashboard from the non-profit organization Our World in Data, which tracks a range of indicators related to health and social policy. And these data are essential for organizations like the Gates Foundation and the World Health Organization because it helps them to develop a nuanced understanding of the problems that they're facing and track whether they are making progress towards solving them. So these data help these organizations decide where funding should be allocated, which areas need better infrastructure or training, and which further research should be prioritized. I see that my notes are cut off here, which is unfortunate. Thank you. In essence, a data dashboard like this provides an empirical measure of progress, so that rather than guessing or hoping, these organizations can make informed policy decisions. Now, imagine if we could also do this for science, and that is the goal of the Open Science Observatory. So the notion that scientists should be transparent and expose their claims to the scrutiny of others is a foundational scientific principle, as exemplified in the motto of the Royal Society, take nobody's word for it. And you'll be aware that the last decade has seen considerable disruption in the scientific ecosystem, including efforts to try and improve the uptake of transparent research practices, such as journal policies to improve data sharing. But amongst all of this upheaval, how do we know how much tangible progress has been made? If we simply try to intervene on the scientific ecosystem without evaluating our actions and measuring our progress, then there's a danger that we'll make inefficient, ineffective, or even harmful policy decisions. So that's where we come in. The Open Science Observatory will provide a continuous, large-scale monitoring of transparent research practices in the academic literature across fields and across time. So just as astronomers build maps of the night sky, the Open Science Observatory will produce maps of the research transparency landscape. And that will enable us to gauge the health of the academic literature and adapt our efforts towards improving it. So this data will help us to avoid becoming either despondent because we think that nothing is improving, or complacent because we think that everything is fine. So in other words, the Open Science Observatory will provide an empirical measure of progress towards improving the transparency of scientific research. So how are we going to do this? The core output of the Open Science Observatory is a data dashboard, just like Our World in Data, although we also anticipate publishing our results in traditional scientific papers. The data dashboard will be an accessible, engaging, and interactive way to communicate the results of the project. The data itself is going to come from two sources. Firstly, a globally distributed crowdsourced community who manually assess whether articles are adhering to various transparent research practices. And secondly, text mining and machine learning algorithms, which can automatically assess large numbers of articles. So let me explain why we need both of these data streams. This graph shows the results of some of our team's prior work that estimated the prevalence of various transparent research practices in different scientific domains. So to do this, we work in relatively small teams of around 6 people, and we manually assess whether articles are using these transparent research practices. And we're typically looking at random samples of around 150 articles in each domain. So as you can see, some of the results are pretty sobering. So, for example, we estimate that only 2% of empirical psychology articles were sharing data. Only 1% were sharing analysis scripts. And only 3% were pre-registered. So this is the kind of data that we'd like to see in the Open Science Observatory, but there are some important limitations to this manual assessment approach. Firstly, these prevalence estimates that I showed you represent just a static snapshot of what was happening with articles that were published between 2014 and 2017. So those estimates quickly become outdated. Secondly, these data can give us a broad overview of what's happening across an entire field, but the sample size is not big enough to ask more granular questions, like what's happening in different subfields with different research designs or particular journals. In short, the scope of this data is seriously limited by the labor burden that's involved in doing this kind of manual assessment. So one way to get beyond that bottleneck of manual assessment is to use automated algorithms. And our team member, Stylianos, previously used text mining algorithms to assess transparency indicators in 2.75 million open access biomedical articles. And you can immediately see the advantage that doing this kind of large-scale analysis is that we can look at temporal trends over time. You can see, for example, here that since the year 2000, there's been a substantial improvement in conflict of interest and funding disclosures, relatively modest improvement in data sharing, and barely any improvement in code sharing or pre-registration. Now, it's really important that when we use these automated tools, we know how accurate they are in specific contexts. So if we want to use this algorithm in a different field or to look at a specific journal, for example, we would need to revalidate and potentially recalibrate that algorithm. Additionally, the way that these transparency indicators are reported in the scientific literature is constantly evolving, so there's an ongoing need to recalibrate and revalidate algorithms. To do this, you need to compare the performance of the algorithm to a gold standard benchmark, and the best benchmark that we have in this context comes from manual evaluation of the articles by several coders. So crucially, even if you want to use automated algorithms, you still need to have some manual evaluation. So that's why the Open Science Observatory is going to combine both of these two approaches. Manual assessment will create gold standard benchmark data that can be then used to develop and validate algorithms that enable rapid and large-scale assessment. Now, the amount of benchmarking data that we're going to need is still beyond the scope of a small team, so that's why we're going to start using crowdsourcing to drive this data collection effort. And let me say a little bit more about how that will work. So at the core of the crowdsourcing system is a central pool of articles which is selected by our team. And community members will be able to log into the platform at any time and draw down articles to work on at their own convenience. We will provide training and standardized data entry forms, and data quality will be ensured by cross-checking classifications between multiple contributors. We're then going to actively build this community, partly by leveraging existing networks that we're part of. For example, we'll organize hackathons at key conferences and create exercises for students and journal clubs. And you may wonder why people would want to contribute data to this platform. Well, partly we're relying on traditional academic incentives, so we believe that people are going to be engaged with the mission, and all contributors will be eligible for authorship on any academic publications that come out of the platform. But we're also going to build a community. So our crowdsourcing approach will follow a model that's been successfully demonstrated in the context of the Replicats project, which was led by our team member Fallon. The Replicats project successfully built a community of over 1,200 participants who made over 330,000 credibility judgments for over 4,000 academic papers. Fallon and her team achieved this by creating a really fun and engaging community. So they used an evidence-based gamification strategy in which participants received various prizes and badges, like the Hakuna Matata badge, for achieving various project goals. We're also going to draw lessons from another successful crowdsourcing project, the Cochrane Crowd, which has solicited over 7.6 million judgments about healthcare evidence from over 28,000 contributors, many of them citizen scientists. So in short, we believe that this crowdsourcing approach is feasible based on the success of Cochrane Crowd and the Replicats project. Now, for the automated data stream, there are a few candidate algorithms being developed, and that includes those developed by Stylianos and his colleagues. So one thing we'd like to do is to organize a transparency algorithm challenge. And this is where various groups will pit their algorithms against each other to see which one performs the best. And the Open Science Observatory will provide the gold standard benchmarking data freely available for anyone to train and validate their algorithms against. So we're hoping to catalyze innovation in this space. So I'll wrap up now with a few final words. So we've been thinking carefully about the future of the Open Science Observatory in terms of both its sustainability and possible expansion. So if we have capacity, we can start to monitor other information beyond transparency, like indicators of research quality and bias. We're also going to seek to develop funding partnerships with organizations like academic publishers that use our platform to track their progress towards their own institutional goals. And we're also going to develop a training and mentorship scheme so that we can build leadership capacity in our own community, so that there's no dependence on any particular individuals in our core team. And finally, following the model of organizations like Our World in Data, We may eventually seek to establish ourselves as a non-profit organization. 2 of our team members have worked for non-profits, and both Stanford and Melbourne universities provide financial and logistical support for doing this. So, in a nutshell, the Open Science Observatory will provide an empirical measure of progress that guides us as we seek to improve the transparency of scientific research. Well, thank you so much for listening, and I look forward to answering any questions you may have.